Okay, so today we're going to be talking about graphing exponential functions, moving away from solving those equations and going into functions. So now we're going to have a y equals to some function that has an x in it. So we're going to have two variables graphing. So with exponential functions, like our equations, the variable is in the exponent. And a function because there's going to be an input and an output. Okay, so here's our input variable, here's our output, and we have our base. Now, our base cannot be 1 for this to work, because 1 to any power is just going to be 1. So it wouldn't create that exponential growth that we're looking for. And then here's our exponent, which has our x variable in it. Okay, so there's two possibilities that could happen here when we look at exponential functions. One is that we have exponential growth happening, and the other is that we have exponential decay happening. So growth happens when our base is greater than 1. So for example, if I had y equals 2 to the x, this equation or this function would be a growth function. The graph of this growth function would look like this. That's what exponential growth looks like. Notice how over here it kind of like almost touches 0, but never really crosses 0. It's just getting smaller and smaller and smaller. And what's happening here is if I think about the exponents, okay, 2 to the 0 would be 1, 2 to the negative first, 1/2, 2 to the negative second, 1/4, 1/8, 1/16. We're going to get smaller and smaller and smaller. But there's no x value, positive or negative, that's going to make our result be a negative number. So we're never crossing this line. And that's something that's down here that we're going to talk about. This is a new to our graphs where we have an asymptote. Okay. Now an asymptote is a line that a function approaches but will never cross. So this function is approaching the x-axis or approaching 0, okay, but it's never going to cross, it's never going to be 0. Okay, there's no exponent, there's no x value that would make this equal 0. And it's never going to become negative. Okay, now it's a horizontal asymptote, it's a horizontal line. Okay, it's approaching this horizontal line. We know that horizontal lines, we called them hoi at the beginning of the year, because that meant it was a horizontal line with 0 slope, and it was y equals a number. So we can find the equation for our asymptote. This equation would be y equals 0. That would be our horizontal asymptote here, is y equals 0. It's approaching 0, but we'll never hit it. Now, same idea is going to happen for our decay. In order for something to be exponential decay, our base has to be between 0 and 1, or a fraction less than 1. Okay, so for example, y equals 1/2 to the x power. Okay, this base is between 0 and 1. It's a fraction less than 1. And exponential decay has a graph that looks like this. And again, it's approaching 0, but will never cross 0 for this particular example. Okay, so again, I have this horizontal asymptote at y equals 0. Okay, and so that's kind of just an introduction to these functions and what their graphs look like. We have growth when our base is greater than 1. And we have decay when our base is a fraction and it's between 0 and 1, less than 1. Growth graph, decay graph. All of our exponential functions will have a horizontal asymptote that we will include and write the equation for. Okay, so first we're going to do an investigation today. So we're really just kind of like dipping our feet in, and then we'll talk more in depth about how different parts of our function kind of transform the graph and how that moves around. So we're going to look at that growth equation I had up above. So y equals 2 to the x. And we're going to create a table here. So if I have x is -2 That means I have 2 to the negative second, and we know that negative exponents mean we move it to the denominator, or this would become 1/4. Okay, if I plugged in -1 into this function for x, then I'd have 1/2. If I plugged in 0, anything to the 0 power is 1. If I plugged in 1, 2 to the first is 2. And last, if I plugged in 2, 2 squared is 4. Okay, so just plugging in values for x, we can get a little table here. It's going to give us a sketch of our graph. So I have -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. And that gives us a good sketch. Ooh, don't want to go up there. Good sketch of our graph. Okay, and arrows on both ends. Now, again, we looked at it up above. Even if I go more and more negative, it's just going to become a smaller fraction. We can kind of see what's going on there. So this graph is approaching 0. I have a horizontal asymptote where y is 0. So my equation for my horizontal asymptote is y equals 0. Okay, it's becoming a smaller and smaller fraction. Okay, so the function becomes a smaller fraction as x goes towards -infinity. As it gets more and more negative, it will never hit 0. Never hit 0. Okay, there's no x value that I could plug in that would make my output be 0. Okay. Now, the other thing we want to talk about, and this is going to become a really important piece to us, is the y-intercept. So our y-intercept, where it's crossing the y-axis, we can see is 0, 1. Now, any base raised to a 0 exponent is going to be 1. So it doesn't matter if the base is 2 or 1/2 or 57. Okay, if I raise it to the 0 power, it's going to become 1. So we use this point to help us graph and to help us transform a graph and get kind of a good sketch of what it would look like. So this point, this 0, 1 point, is going to be really important to us moving forward. I call this point the anchor point. We take that point, because it's always going to be the same initially for any function. When I plug in, for any base, when I plug in 0, it's going to give me an output of 1. So if I have 0, 1, and then if I add to my function, how does that 0, 1 change? And that gives us a point to anchor our graph. Okay, so just kind of, we're going to keep mentioning the anchor point as we move forward. So now let's do a little investigation of how our graphs do move based on different things we add into our function. So we're calling y equals 2x our parent function. So we're comparing all of these functions below to our parent function, which we just graphed. So I'm just going to graph it again. -2, 1/4, -1/2, 0, 1. There's our anchor point. 1, 2, and 2, 4. That's just redrawing the graph from the other page so we remember it and we can see what it looks like. And this graph has a y-intercept of 0, 1. And this is our anchor point. I'm going to abbreviate anchor point as AP. And it had a horizontal asymptote at y equals 0. Okay, there's our parent function. And now we're going to use Desmos to look at how our parent function changes as we alter things about that function or add things in. Okay. So first, let me share Desmos instead, and we'll kind of flip back and forth between. Where's my Desmos? So I have it set up in here where I have my y equals 2, the x, my parent function, and I have it again here. I'm going to turn that one on. So it's the same function, it's just covering it up at this point. Now, the first part of this investigation says, well, what if we put a negative in front of that parent function? I'm going to go ahead and do that. We're going to look and see what happens. Putting a negative in front of that function appeared to flip it, right? And it flips over the x-axis. And now that growth is going, it's upside down. Okay. Now, before we go back to our page, let's also look at the second part of that, which is what if I put a negative in the exponent? I'm going to put a negative up there and let's watch what happens. I'm putting a negative in the exponent flips it over the y-axis. Okay, see how that graph, that red graph, if I just flipped it over, now I have that blue graph, but flipping over the y-axis. So going back to my notes here, let's write what we observed for these first two. So here, this flipped over the x-axis versus here, it flipped over the y-axis. Okay, that's what we observed. And so I'm going to draw a quick little visual of what we observed. This growth function started like this, okay, approaching that horizontal asymptote. When I added that negative out front, my graph became this, flipped over the x-axis. Still approaching zero, but approaching zero from the other side. So what happened to my anchor point? My anchor point, which is here, went to here. So what happened to my anchor point is it went from 0, 1 to 0, -1. I got multiplied actually by that negative out front, -1. And that's what happened to all my points. It gets multiplied by that negative and it's flipping it upside down. Okay, and over here when it flipped over the y-axis, so here's my initial graph, anchor point there, horizontal asymptote. And when we put a negative in the exponent, what we observed happen was it flipped over the y-axis. Now, did that change my anchor point at all? No, okay, it didn't change my anchor point, didn't change my horizontal asymptote. So here, my horizontal asymptote also just didn't change. Okay, this is still a horizontal asymptote of y equals 0 and an anchor point of 0, 1. So it didn't change my anchor point at all. It didn't change my horizontal asymptote at all here. It just flipped it over the y-axis when I add a negative into the exponent. To be honest, we don't do a lot of these transformations in this when we're working on our graphs, but we do see this one a lot. And so we have to think about how that's going to change my graph. Okay, flipping it over the x-axis. Okay. Let's move on and look at another transformation here. So I'm going to take my parent function, I'm going to multiply by 3 out front. So let's go back to our Desmos, get that out of there. So there's my parent function. And if out front I do 3 times, let's look at what happened. So it's still approaching 0, it's still growth here. And what happened was my anchor point went from 0, 1 to 0, 3. Okay, that my y-intercept shifted. So for this, filling this in, really it's just multiplying by 3, which I want to point out that up above, my anchor point multiplied by -1. Now, if it was -3 out front, it'd change that anchor point by -3, it'd multiply it by -3. Okay, so what happened is our graph still grow, but it shifted a little bit. It's still approaching 0, but it's crossing, I don't know how good I did there, a little bit higher up. Okay, so instead of crossing at 0, 1, it's crossing at 0, 3. It shifted that anchor point. The anchor point went from 0, 1 to 0, 3. And what's happening is it multiplied by 3. Okay, did it change our horizontal asymptote? No, we're still approaching 0. Okay, that one's kind of a standalone one. Now I'm going to look at the next two together. So first I have a transformation where in my exponent I'm subtracting 2, and then I have in my exponent I'm adding 3. So I'm going to do this the same. It's going to be the same kind of type of shift. We're going to look at both of those. And then return to our notes. So let me head back to Desmos. Get this other one out of here. Okay, so the next transformation we have is, well, what if in our exponent we subtract 2? subtract, oops, it's gonna be my exponent. Right now. Maybe I gotta put a parenthesis around it. I'm gonna subtract 2. What happened there? Let's look at, what if I subtract 5? Okay. What if I subtract 10? Ooh. Okay, so you can see the more we subtract, the more my graph shifts to the right. Okay. What if I, on the other one, it's add 3. So I'm going to add 3. Shifted to the left, 3. Okay. If I add 6, shifts even more. If I add 10, shifts even more to the left. Okay. So we can see that, sorry, I had to pause the video for a minute. So one minute, let me regroup. So what we see there is this X value change. We're seeing this horizontal shift. We're either going to the right or we're going to the left. So let me go back to our notes and let's write what we observed here. So how does that change our anchor point? So we had this graph, just doing a sketch of our original graph. Anchor point is 0, 1. Now when we shift, when we add 2, and it's a horizontal shift, our horizontal axis is our x-axis. So it's a +2 to our x value. So what happens, my graph shifted over a little bit, poor graph there, and my anchor point changes to 2, 1. And what's happening is it's an x value change. I am adding 2 to the x value from this shift here. Notice it's opposite, right? So it's x minus 2 actually adds 2 to the x value or shifts it to the right. Whereas x plus 3 shifted it to the left. We had our graph here at 0, 1. And when we add 3 to our exponent, it shifted it to the left and it made that point -3, 1. Okay, or it's subtracting 3 from the x value, okay, and it's only the x value that changed from my anchor point. Okay, so 0, 1 became 2, 1 when I subtracted 2 from my exponent, and when I add 3, becomes -3, 1. Subtracting a value from my exponent shifts it to the right. Shift to the right, and subtract or adding 3 or adding any number to my exponent will shift my function to the left. Now, did the horizontal asymptote change at all for this? No, it's still approaching 0. Okay, no change to that horizontal asymptote. See here, no change, no change. Okay. So we observed that negative out front flips over the x-axis, negative in my exponent over to y. Any multiple out front multiplies my anchor point, okay, shifts it by that multiple. Should be putting arrows on these. And if I add or subtract inside my exponent, it's a horizontal shift, a left-right shift. Well, what if I add or subtract outside of my exponent? So let's go back to Desmos and look at this last transformation here. So what if I add or subtract outside? So the first one in our notes is to add 3 at the end. So I'm no longer in my exponent, I'm going to just add 3. Okay, so if I add 6, oh, up even higher. And the other one is if I subtract 1. I subtract 1. Okay, what if I subtract 4? Okay, and so what you should be seeing here is that that is a vertical shift, right? It's moving it up. If I'm adding 3, like the first one, shifting it up. And if I subtract 1, like the second one, it shifts it down. Now, I want to talk about what happens when I shift it up. You can see that the horizontal asymptote has moved with it, right? Now it's approaching 3 instead of approaching 0. Do you see here's 3 right here? It's getting close to 3, see that? But it's never quite going to be 3. It's just going to get really, really close to it. And when I subtract 1, now instead of approaching 0, I'm approaching that -1. Let me show you. I'm approaching -1, not quite getting to -1, getting closer and closer and closer each time, okay? So one thing that's important to know is that with this vertical shift, this up-down movement, we are also changing our horizontal asymptote, and that's super important. So what happened to our graph? We went from here with an anchor point at 0, 1, and a horizontal asymptote originally was at y equals 0. When we add 3, our graph shifted up 3. And notice that it wasn't at, it didn't shift to 0, 3, it shifted to 0, 4. And my asymptote that I was approaching shifted up 3. So that my horizontal asymptote is now at y equals 3. So that move up 3 moved our asymptote up 3 and this point up 3. So I'm taking 0, 1, and I'm adding 3 to the y value. And then I'm taking my asymptote from my parent function, and I'm also shifting that up 3. Okay, so what we observed when we added 3 is we moved up 3 units, and it's a y value change. When we subtracted 1 at the end, here's my parent function. We also had this vertical shift, so 0, 1. Our horizontal asymptote originally is at y equals 0. And then when I subtract 1, I shifted down 1. And now, instead of approaching 0, I'm approaching -1. Okay, my asymptote moved down 1. Instead of my anchor point being at 0, 1, now it's at 0, 0, which is just taking that y value and subtracting 1 from the y value. Okay. So I went down 1 unit, and it's a y value change. Okay, so now let's put this all together. So we want to write an exponential function with a base of 2 that transforms the parent graph. So let me just y equals 2 to the x. Okay, there's our parent function. We want to transform it in the following ways. We want it to go up 4, left 2, x-axis reflection. Okay, so let's start with the up 4. If I want to go up 4, that's the transformation we just looked at. So shifting this graph up 4 means I'd be adding 4 outside of my exponent at the tail end of that function. Okay. If I want to, let me just get another color here. If I want to go left 2, well, our right-left change is right here. If I want to go to the right, if I want to go to the left. And remember, it was kind of opposite, right? So when I subtract 2, I actually go +2. If I add 3, I actually go -3. So if we want to shift left, we want to be adding that value into our exponent. We want to add 2 to our exponent. And then our reflections are up at the top. An x-axis reflection, so over the x-axis means there's a negative out front. X-axis reflection, negative out front. So we know that if we were to look at this graph, it would be flipped over the x-axis. It would go left 2 and up 4. Okay, let's try to draw a sketch of what that would look like. So here's my original graph. Okay, now if we, let's kind of start at the beginning. First, flip over the x-axis. Flip over the x-axis. Let's go one at a time. Now my graph looks like this. Then let's go left 2. Left 2. Meaning it's going to move over a little bit to here. And then we go up 4 at the end. So I flip over the x-axis, go left 2, and then up 4, which means this is going to shift up. Maybe look something like that. I may have drawn that too far over. Okay, but that's kind of what my final graph will look like. So I went from a parent function, a growth function, flipped it over, went left 2, up 4, and that's a really rough sketch. Let's look at it in Desmos real quick. Okay, so here's my function. I'm gonna flip it over the x-axis. There's the first change. We wanted to go left 2, so add 2. There's my left 2. Then we want to go up 4. Add 4 at the end. And there's my graph. But I match my sketch pretty well. I'm a little too high up on my y-intercept, but overall I'm okay. Okay, so that's how I can kind of put those transformations together and have multiple things happen to this parent function where I'm flipping, shifting left, right, shifting up, down, giving me a new exponential function graph.